Hello guys, this is Hassan Kucheki, and this is the first video of the new series of teaching basic and fundamental concepts about the course Fundamentals of Programming. This course is the first course the computer science students would attend to, and in this series I want to teach basic concepts and especially in short videos. In this video, I'm going to write a program that takes two numbers like A and B, and A is the start of a sequence and B is the uh, ending point for that array, that sequence, and we want to uh, print out the prime numbers between these two numbers. So in the first step, we need to define our uh, A and B, and then seeing these two numbers. Here, if we print out the A and B, we can see that our program uh, working not correctly because we are compiling another file, and by that, if we, for example, input 5 and 16, we could see this program working correctly. Okay, now we have the ending and the starting point of our sequence. Now we need to loop over these two numbers, so we write int I, starting from A until I is less than or equal B and I plus plus. Okay, uh, let's visualize that. Here, for example, we have 5 and uh, 16, for example. This is our sequence. We need to write the whole sequence. Okay, this is the sequence we have, and we need to loop over that. Actually, this loop just pick each of these numbers, and for example, we can print out or uh, do other stuff. This loop just selecting each of these numbers at each time step. Okay. Uh, After picking the first number, for example, this is 5, we need to check if it's prime or not. So here, check if the number is prime or not. Okay. Here we have 5. I is equal to 5. We need to check if 5 is prime or not. So we need another loop uh, int j starting from 2. J is less than our number, which is here is I, and here. So here we have all the numbers are less than 5. For example, in this example, numbers produced by this loop are 2, 3, 4. To check that if a number is prime or not, we need to divide that number by all of the uh, numbers that are less than that number. So here we write a loop I, uh, remainder of I by j if equal to 0. It means I is divided by one of these numbers. Okay, for the first run of this code, we pick up 5 as I, and in this loop, j, the first value of j is 2. So we have 5 divided by remainder of 5 divided by 2 is 1. So it's not equal to 1, so we skip. Uh, Here we can conclude that the number is divided by j, so it is not prime. Also we can write I is not prime. Let's run this code. We need to use, for example, 5 and 6. Here you can see that it checks all of the numbers, and for example 13 is prime, it doesn't print here. So we need to print the prime numbers. Okay, so we need to reverse and make a little modification here. The first thing we need to is that we want to write the prime numbers. Okay, so after this for loop ends and we didn't enter this if, we can conclude that the number which is here is I is not divided by any of numbers that are less than its numbers. So we can conclude that the number is prime. So here we can uh, add not. Okay, but the problem here is that we need to check that if we didn't ever uh, go through this if. Okay, so at the first we need to define a boolean and call it is prime. At the first of the program, we assume that the number which is here is I, stands for each of this number. We assume that is prime by default. So when we start the program, we set this flag is prime equal to true. If we enter that if a statement, we know the number is not prime. Okay, so we need to reverse and change the its prime value to the false value. Okay, when we divide I by j and we have some remainder other than 0, we don't go inside this if statement, and if it's divided by j, we understand that the number is divided and it's not prime, so we set the is prime flag to false. Here we need to check if we get into this if statement. So if is prime is equal to true, it means we never get into this if statement, so we can print the number. Let's run the program. 5 and 16. We need to remove this. Okay, here we saw that 5, 7, 11 and 13 are prime numbers and printed out correctly. We can also some modification to speed up our program. Let's run an example. For example, we want to check if 20 is prime or not. Here what we do is that get all of the numbers less than 20 and divide 20 by all of these numbers. Okay, and check that if these are divide, these are can these are some numbers that can divide our number, which is here is 20. So I put a star under each of these numbers that can divide 20. 2 can divide it, 4 can, 5 can, and also 10 can, and the rest of the numbers can't divide 20. So if we draw this sequence for all of the numbers, we can see that the numbers that can successfully divide our desired number are all in the range of this half sequence. Okay, so we have a sequence by the length of 20. All of the numbers that can divide 20 are in the first half. So we here can uh, change this uh, condition to divide by 2. Okay, and we just add one number. Do not exactly check the middle number. We just check one more. Um, Here for 20, we divide the 20 by 2, which is 10, and divide it and plus it by 1, which is 11. We just check these numbers. Okay, by checking these numbers to see if they can divide 20 or not, we can bypass the checking for the rest of the numbers which are in large numbers, which is too much and can significantly reduce the time for running the program. So here we cut off the half of the array which we can speed up our program. The other thing is that when we are trying to uh, divide 20 by each of these numbers, uh, by the first number that divides the 20, we can conclude that the number is not prime. Okay, uh, so this program actually checks 2, then 3, then 4, then 5, then and goes through 11. But we know that if a number uh, divides the desired number, the desired number is not prime. Okay, so by checking the 20 is divisible by 2, we don't need to check the rest of the numbers because it's divided by 2 and we know that it's not prime. So we can put a break here to stop checking the rest of the numbers as soon as we find a number that can divide our desired number. So now let's run the program, and we can see the program is working with much less time compared to our first program. Um, that's it for this uh, little program. I hope you find it uh, useful. Thank you, take care, and goodbye.